Good morning, ladies and gentlemen. We are going to start discussing the integral mathematics, and the integral, which is regarded as the integration, from the definition context, it's defined as the reverse process. The reverse process of differentiation. So the reverse process of differentiation is actually called integration. Like we are saying y is equal to x to the power n. So we are saying y prime is equal to nxn minus 1. So as a reverse process, the integral, it's like you have got this one, which is the nx n minus 1. So here you add 1. I can change the color for this. You add 1. You actually say 1 plus 1, and then you divide by the product, this one, and then you put a constant k. So at the end, you actually have got now y is equal to nx to the power n over n. So this and this cancel. So in the process, you have got xn. So that's the reverse process. So in terms of the symbol, we actually use the integral, and we can actually say y is equal to xn. Now because we are integrating this one, then we put dx, implying that we have got an integration. So this particular symbol is called an integral. It's called an integral. So we can actually say the definition of an integration, this is equal to the integral of f of x dx is equal to capital F bracket x plus c. So this is the definition of integral when f prime x is equal to small x. So this is the definition. So having said that, then we can be able to actually define some important elements. Now having done that, which could be like the following. Let's assume we have got now a statement which is integral of 2x squared plus 2x plus 5, or minus 5 bracket dx. If we have got something like this, then what you normally do is you can be able to integrate each one independently, and then the integral can be like this, and then the integral plus minus 5 integral dx. So in this case, you can be able to now integrate the inner one, then it can be 2 multiplied by x2 plus 1 over 2 plus 1, and plus 2x 1 plus 1 over 1 plus 1, and then minus 5 x to the power 0 plus 1 over 0 plus 1, and then you put a constant, taking into consideration the arbitrary value that actually vanished. So it can be now 2 over 3 x to the power 3, okay, and plus x to the power 2 minus 5x, and then plus a constant, which is k. So this is actually the integral of that particular sum. So we can be able now to understand that in a general term, we can actually say the integral of x to the power a multiplied by dx is the same as 1 over a plus a1, like that, and multiplied by x 1 plus 1a, and then thereafter you put plus constant, and this you make sure that a is not equal to -1, so that this one is not negative, because if it is negative, then the whole expression here becomes infinity, and we try to avoid that particular situation to happen. So we control for that particular part. Having done that, then let's look at the different forms of integration that we can have, which can be considered. Like for example, if we have got an integral of 1 over x dx, this is the same as natural log of x plus c. This is assume that x is always greater than 0. Remember, x must not be equal to 0 because this can become infinite. And then we can actually have another one, ax and dx. And this is the same as you always take like u is equal to ax. So if you take an integral of eu is the same as eu plus k. Okay, let now when you have got this one, then you actually now say you actually remove this by the integration, so you can actually say du dx is equal to a. Then in this case du is going to be equal to a is equal to dx. So having done that, then you can come back to the expression. So the integral, it can be u multiplied by dx. So when dx in this case is equal to du, so this implies that I can have eu multiplied by du over a, over 1 over a with a constant. That's why I'm taking it out. So in that case, now you can now integrate that. So it is going to be equal to 1 over a multiplied by eu, which is eu is equal to ax plus k. So this is actually the value for that particular statement. So we normal and you make sure that a again is not equal to 0, because you should avoid dividing that value by 0. So that's the way we can be able to look at the integral mathematics from that particular point. Now, having done that, I want us now to look at what if we have got an integral of ax and the dx. What if you have got this particular statement? Now, according to the rule of calculus, this is the same as 1 over natural log of a, okay, 1 over natural log of a x plus c. And we actually say a must always be equal to 0, and the a is not equal to 1. So this condition must be observed. So I want us to understand the way we can be able to apply. For example, you can actually have like 4 to the power x dx. So this is the same as 1 over natural log of 4x bracket plus any constant which can come. So you can easily now get this one. So this is like x natural log of 4. So you can easily get natural log of 4 and then get the value, and that you can actually have plus k on the other side. So this becomes 1 over as a reciprocal of the function. Now, having done that, then I will be able now to go into some general rules, of integration. Now, the integral of this one is fx like dx. This is the same as integral of a bracket fx dx. So this is the first one. And if we have got an integral of fx positive negative gx, like this one, in a bracket dx, then is the same as integral of fx dx plus negative integral of gx dx. So this is actually the integral, the mathematics that we can have. So we can be able to separate them in that particular statement. So we have got so many rules that can be associated with that. Now, the one which I just deleted, it is called additional rule, and we have got so many now that can be associated with the additional rule, the additional rules that can be done. So let's look at the other concept, which is actually regarded as the definite integral. Now, the definite integral, this is actually the integration that actually appear in this particular form, dx. And in this case, you can be able now to look at the limits. So based on the definition, this is the same as b a, and then if I put capital F, it means that I have integrated, and if I put capital B, capital F have integrated. So at the end of the day, you actually look at where f prime, in this case, where f, sorry, is any function satisfying f prime x is equal to fx for all x is an element of for all x is an element of a to b. So this is the way we actually can be able to do our problem. So that's the most critical processes that we normally can be able to look at. So having done that, we can be able to actually get like an example. We can have a problem where I've got 3, 1, and then 3x over 10, and then here dx. So can you find the integral of this statement with limits involved? So in that process, what you normally do is you actually look at the integral of that. So it is going to be equal to integral of 3x 1 plus 1 over 1 plus 1. Now because this is a 10, then it becomes 1 over 10 outside the bracket, 1 over 10, and then thereafter you actually put 3 and 1 so that you can be able to substitute, which normally becomes 1 over 10, or it can be 3 over 10, 3 over 10, and then we have got multiplied by x to the power 2 over 2 at the bottom. So it means that it can be now 3 over 20 x to the power 2. So in the end, you can now substitute wherever there is x, you substitute 3, and then thereafter, you actually can be able to take this again. Wherever there is 1, you substitute 1, and then you take the difference. Then at the end, you actually have got the value that you can be able to get. So that particular value is what defines the statement. That's the most important part. And on the other part, we can be able to actually have so many examples which I can be able to give you so that you can be able to practice, which looks at the integral. Now, finally, I want us to look at it in this particular way. We have got a statement. If we have got an integral of b over a, we have got f of x and dx. This is the same as negative of a over b, so it's like reciprocating. So you can be able to take f dx. So this is the way it can happen. So you can be able to actually reverse them. And at the same time, the integral of a fx dx, the answer is 0. And that's the way we normally put it in that level. So these are some of the properties that defines the integral. And the secondary, if we have got an integral of b a fx dx, okay, is the same as integral of c a fx dx plus the integral of b c, and we've got fx dx. So we have got these statements which normally can be able to define the values that we have in that level. So at the end, we are able to determine the actual values that we have in a statement. So these are the processes that defines the Riemann or the Riemann sum. So in the next section, we'll discuss now the application of these, looking at the consumer and the producer surplus. So we'll be able to look at the consumer and producer surplus in the next section. Thank you. We are